Who is that? Okay. All right. Hope everybody's doing okay. Just watching these videos and using that to help you with the classwork. You should definitely be working together in groups on these classwork assignments. And you know, for those of you who have watched the YouTube videos, please share your notes and you know, whatever you learned from these videos with your other classmates. Okay, so tomorrow you're going to be going over eclipses. Okay, so the aim is how do eclipses occur? So that's for November 15th, Tuesday. Okay, how do eclipses occur? Real quick though, before I go into that aim, I should just go over the classwork from today. And so, let me see, I don't know how, I guess this should be a good distance for the camera. So the sun is coming from over here, and remember, you're supposed to use that technique I showed you in the last video, using the T diagram and then covering up the half that's faced away, and then determining what this phase of the moon will look like when viewed from Earth. Okay, so for position 1, that's going to be what we call the new moon, and that's where the shaded half of the moon is facing the Earth. So it's completely darkened in. That's how you should have done it. For position 2, there's only a little bit on the right hand side that'll be lit up, so it should look like that. Position number 3, it basically looks just like that. Okay, on the right half is lit up, the left half is darkened. For position 4, most of the right hand side is lit up and a little bit on the left is darkened. Position 5 is the full moon, okay, because that's the lit half of the moon is facing the Earth. Position 6, so I could turn the paper here and you'd see, if you were looking at that, there's a little bit on the right that'll be darkened and the rest will be light. So a little bit on the right dark and the rest is lit up. Here we got half and half, so it's when you're looking down towards 7, it's kind of like 3, but it's the reverse, right? So if I turn the paper like this, it might be easier to see. If you were looking up at that moon at night, the right half would be darkened, the left half would be lit up. So for 7, right half is dark, left hand is lit up. Okay, and then number 8 would be another one of these crescent moons. Okay, in this case the left half of the moon is going to have a little sliver of light. Okay, so that's it for that one. I'm going to use the same diagram to show you about eclipses. Let's see here. So there's 2 types of eclipses. There's the lunar eclipse and the solar eclipse. With the lunar eclipse, that just means it's a situation where instead of the moon being lit up by the sun, the light is blocked out. Okay, so it's darkened, and the reason that happens is because when you have the sun shining on the Earth, right? The Earth is then going to have a shadow behind it, and that shadow is going to fall. So here's the sun, like this. Well, it's not really exactly, it's not exactly a scale, but basically what's going to happen is this. Okay, this whole thing here, the shadow from Earth falls on the moon, and instead of seeing a full moon like normal, every once in a while you'll see a lunar eclipse. Okay, so this half of the moon that should be lit up by the sun, instead it's fallen into Earth's shadow, so now it's darkened. Okay, and you might say, well, how come we ever see a full moon then? When the moon is in this position, shouldn't it always be in the shadow of Earth? How is it possible that we get a full moon? And the truth of the matter is, lunar eclipses, where it's in Earth's shadow, are fairly uncommon. They don't happen every month. Okay, so it's not happening every time moon is in this position. Why? It's because the sun, the Earth, and the moon when the moon goes around the Earth. Okay, so this is a top view that we're looking at here. But if we can imagine looking at a side view for a moment, in fact, you know, if basically this whole thing, I turned it on edge, and you're looking at it like this. Okay, imagine that for the moment. Okay, so basically what it means is, you know what, let me take this other board here and I'll draw it on this. So it would be like, here's the suns, and here's the Earth, and I'll draw more of the side view now. So here's the moon, and it's going around like this, right? And here's the moon over here. But the truth of the matter is, the moon doesn't usually go around the Earth in a perfect line with the sun. Okay, it doesn't usually go in a perfect line with the sun. The way the moon usually revolves around the Earth, it's on a tilt. So it's like the moon is here, and it's going around like this. Okay? So you can imagine then that Earth's shadow is not really going to affect the moon if the moon is a little bit above that shadow. The sun's light will still hit the moon. Okay? And that's usually what happens. Usually when the moon is in position 5 here, when the moon is in position 5, it's a little bit above the Earth's shadow. Okay, again, look at the side view. Here's the side view. The moon is either a little bit above or it might be below too. It could be this situation where the tilted orbit is so that the moon is lower here. Okay? In any case, it's not usually like this. When this does happen, when the moon happens to be right in a position in line with the sun, earth, moon, that's when you'll get the actual lunar eclipse, okay, where it's blocked out. Alright, and then the other type of eclipse is called a solar eclipse. And that's where the sun looks blocked out. Instead of the moon looking blocked out, it would be where the sun looks blocked out during the day. And these are even more rare. Okay, they happen even less frequently. In fact, I don't think a solar eclipse, a total solar eclipse, is supposed to happen even in the Northeast for another couple of years. Okay, so, and probably not going to happen in New York for, I don't know, who knows, 50, 60 years. I haven't checked. I should go check and see. But they're rare, so let's just put it that way. And they only last for a few minutes. A lunar eclipse could last for a couple of hours, potentially. Alright, so getting back to the solar eclipse, so what happens now is the moon gets in the way of the sun, and so from Earth, when we're looking at the sun, the moon blocks out the sun on one spot on Earth. Okay, so it would be like, well, just like this one little spot. This one little spot on Earth, the sun's going to get blocked out. Now again, this diagram of mine, nothing's to scale. I mean, the sun would be much bigger than it is in this picture, but it would also be much further away. So you just have to bear with me here for the inaccuracies here in terms of the size of everything. But the basic idea that you need to understand is that the moon, when it's in this position, every once in a while it could block out the sun from hitting the Earth, and that's what causes the solar eclipse. Okay? Again, why doesn't this happen every month? Because you might say, well, every time the moon is in position 1, shouldn't it block out the sunlight from hitting Earth? But it doesn't, because, again, most of the time the moon isn't going like this. Most of the time, I mean, it's on a tilted orbit, so it's either below or above sunlight coming in, so it doesn't actually block out the sun once every month. It doesn't happen. Okay, it's a rare thing. But when it does happen, that's what's happening. The moon is blocking out the sun from hitting Earth. Okay, so that's a solar eclipse. And then the lunar eclipse would be the rare occasion where the moon falls into Earth's shadow. Okay, and that's pretty much it for eclipses. I guess I could go ahead and tell you the stuff for Friday too. Friday, what am I saying? For Wednesday. That's tides. So Wednesday you're going to do tides. But you know what? So this video isn't too long. Actually, I'm just going to cut it here. Is there anything else I have to mention for eclipses? Emma, you want to come here and say hi to my classes? Come here. Come here. You can say hi to all the kids. I have stuff all over my hands. It's okay. This is Emma. This is my other little girl. Say hi. Say hi to the camera.
Hi.
Okay. Go.
No, it's over here.
Alright, you can stay there. Let me just check my notes real quick. Look at my lesson. You stand on my lessons. Thanks. Let me just see if there's anything else I had to mention. That's pretty much it. So it's positions 1 and 5 that cause the eclipses, and I think that should be good for now. Okay, so all right. I'll see you guys tomorrow.